So let's talk about tabulating the data. Tabulating the data means that I have a data and I want to create a table of that data. I want to see my data in the form of table. Very simple. I can do it. Let's have a look at this code. Here we have created a vector. Vector equals to 2, 4, 3, 1, 2, 3, 2, 1, 4, 2. So this is what? This is my vector. These are my values. Now I'm calling a table function, calling a table, and within brackets I write vector. So vector is what? That is my variable, and I create a table. So you can see the output. Vector 1, 2, 3, 4 becomes your first row, and 2, 4, 2, 2 becomes your second row. So that is how you can create a table. Let's have a large program to create a tabular representation of data. So students, why we go for a tabular representation of data? There is one thing that sometimes the data is very messy. And when the data is messy, in that case, we need to have some kind of representation of the data in the form of some tables or grids so that we can understand it better. So here, let's have a look. We have created a data frame with 2 columns, name and gender. And then we are calling a table function. In the table, we pass the data frame. So here you can see gender is male, female, and name is A, B, C, C, D, E, and D, E, F. So you have name, female, and male. That is where we get the values 0, 1, 0, because the first one is what? It is our 0, which is male. And for female, it is 1. So that is how the data has been tabulated into the form of 0 and 1 and printed on the screen. So very easily you can see the tabular representation of data, because otherwise interpreting male, female, male in the form of list becomes very difficult. Now let's have a look of this example and understand how to make a frequency table. So here in this case, what we have done, we are making a frequency distribution table, which means we have data and we are making a table where for every number, what is the frequency that we have to display. So here in the library function, we have called the package data.table. We are creating a data frame with the help of data.table. And here, first column is a sample, second column are letters, and third columns are again some values. Now we print the data. When we print the data, we write frequency equals to table, and within the table we pass table, data table column 1. And then we write modified frequency table, and then we print frequency, and then we take cumulative frequency table with the function CumSum, and then we store that in the variable CumSum. And likewise we print CumSum, and then we have the third, which is the prob.table, and that we store in the variable probability, and then we print the probability. So that is how basically what we have done is we have taken the library package and we are using the functions of the library package. So the library package is table.data, and we have created a table.data data frame. So basically here this table.data is basically using the functions which are inbuilt of the package data.table. So here the first function is table, the second one is CumSum, and the third one is prop.table. Now let's have a look of this data. Now this is your output. You can see over here that the first output is what? It is my original database. Now you can see that the first column is my value, second column is my ABCD, and the third column is 14122. So you can just go back to the code and understand that in the code, the first column was a sample from 6 to 9, and there were 9 values. If you can see, there 9 times we will generate numbers between the range of 6 to 9, inclusive of 6 to 9. The second column was letters from 1 to 3, which means it will be either A, B, or C. And the third column was again values 1, 4, 1, and it was a vector. So those 3 columns are printed, and that is my original table. After that, we get the modified table. In the modified table, we get the data 6, 7, 8, and 9. So you can see over here that when we are printing the modified frequency table, we are basically finding out the frequency of column 1, which means that my column 1 is having some data and I want to print the frequency of it. So you can see over here that the frequency is coming. So 6, 7, 8, 9 are my values. And if we see that 6 number is present 5 times, so the frequency of 6 is 5, and that is why 5 is written below 6. Likewise, if we see column 1, we see 7 is written only once, which means the frequency of 7 is 1. And like that, 8 is written twice, so the frequency of 8 is 2. And the frequency of 9 is 1. So basically, this is my frequency table. So you can see how quickly I have created a frequency table by just calling the function table and pulling the column 1 and storing that into the frequency variable. And that is how we can also calculate the cumulative frequency table. And there what we are doing, we are having CumSum function, and in the CumSum we are passing the frequency variable. So you can see over here that the output of the CumSum table is there, and that you can see. And then after that you can see that the last thing what we have done is relative frequency. So there we are getting the probability distribution, and then we are printing the probability. So you can see, students, that how quickly we have just called a package data.table and creating a data.table. And the moment we create a package data.table, we are ready to use the functions which are readily available with that package. And how quickly we have created the original data frame, the modified frequency table, the cumulative frequency table, and the relative frequency table. Now we have ordering factor data. Now you must be thinking, what is ordering? So let's have a look at this example. In this example, we will create a factor with strict strings and order the values. So basically, we have called the library package dplyr. So dplyr is our package that we have discussed, and this package is basically called, or you can say loaded, by the library function. We create the factor data with 5 strings. Now our 5 strings are Shravan, Bobby, Pinky, and Shravan. So you can see that it is a factor data, and we have stored that in the factor data. Now display before ordering. So when we display before ordering, we get print factor data, and the output is Shravan, Bobby, Pinky, and Shravan. So this is what it is. Now what I'm doing, I am displaying after ordering. So what I have done, I have called the function as ordered. As ordered is my function, and within brackets I pass factor data. So you can see over here my factor data, it has come, and now I see the output and I see the levels. So it is Bobby is less than Pinky is less than Shravan. Now you must be thinking that how this leveling is done. This leveling is done alphabetically. You can see alphabetically this has been done, and that is how it is coming on the screen. So Bobby is lesser than Pinky is lesser than Shravan, and that is how the ordering of factor variables can be done. We go for ordering of factor variables because sometimes we have a lot of factors and we want to put them in certain orders. Sometimes numeric orders, sometimes character orders, and we need ordering of the data so that when we see the data, it becomes very clear for us, and it is ordered in some with some ascending order or descending order, and it has some kind of logic behind printing it on the screen. So students, I hope with this lecture the concept of data frame is clear to you, and you are able to handle how to deal with the data, add data, delete a data in a data frame, and how to have some kind of frequency distribution tables very easily with the help of including certain packages like data.table through the library function. Stay tuned for my next lecture on list. Thank you.